Assalamu alaikum students. Today we'll be learning about remainder and factor theorem. And as you know, that remainders and factors are a concept related to division. And we know and we are quite familiar with division between numbers. And we know that when you are dividing a number by a certain factor, not really a factor, but a divisor basically, when you divide a number by another number, this number which is dividing is known as the divisor. The number which is being divided is called the dividend. And as a result, the number that you obtain at the top, we know that 5 2s are 10, so we can divide 12 into 5 and we get 2 as a result. And when you subtract the 2, we know that 2 comes as a remainder. All right, so these are certain terms related to division between numbers. This number here at the top is called the quotient. And we can express this whole situation in a different way by writing this statement like this. The dividend is basically the product of the divisor times the quotient added with the remainder. Before we understand remainder and factor theorem, just remember that just like we have division between numbers, in a similar format, we could have division with polynomials. Let's say you have a polynomial x squared plus 3x plus 2, which is being divided by x plus 1. We can go on with this division in a similar way like we divide with numbers. The result of this particular situation is going to be, so for a start, we are trying to get rid of this x square, and we know that x plus 1 times x would give us x square plus x. So subtracting that, we will get rid of these. And as a result, we will have 2x over here plus 2. Now 2x plus 2, how can we divide that with x plus 1? We know that x plus 1 times 2 gives us 2x plus 2. And subtracting these numbers, we get 0 at the end. So this way, we have a polynomial dividing by x plus 1, which gives us a quotient x plus 2, and it doesn't leave a remainder. As you can see at the bottom, everything gets cancelled out. But we are not really concerned about how this division takes place. The idea behind understanding the remainder and factor theorem is that whenever you have a polynomial in terms of x, we call that a function of x, px, and if that polynomial is being divided by a factor, let's say x minus a, then it results in a quotient, which is another function in x, as you can see over here. This answer at the top, the quotient at the top, is another function in x. Let's call that q of x. And in the end, after having these different parts in solving the division sum, you may or may not get a remainder at the end. All right. So whenever we are dividing numbers or polynomials, the idea behind division is quite similar. And again, just like we have dividend equals to divisor times the quotient plus remainder, in a similar way, when we are dividing polynomials, the polynomial in x is a direct result of multiplying the divisor, which in that our situation is x minus a. And when we multiply it with the quotient of x, or the function in another function in x, and when you add it with the remainder, again, the result is going to be equal to the polynomial. All right. So our dividend, when we are dividing expressions, is going to be p of x, our divisor being x minus a, and the result that we get at the top is our quotient, and the remainder we are representing with the letter r. So when this situation happens, we know that we learned in our polynomial identities class earlier that in order to get rid of certain constants from an identity, we try to simplify it by assuming certain values of x. So if let's say, if we imagine or if we suppose the value of x equal to a, what happens to this polynomial? You know that whenever we are replacing or supposing a value of x to be something else, we have to replace wherever there was x in the original identity, we replace all the x's with that alphabet. So in our situation, we are going to replace all x's by a. So when we do that, we see that over here, the divisor, since it's a minus a, that results in a 0. And then 0 times the quotient gives a 0. And this whole expression is eliminated that way. And we only are left with the remainder on the right-hand side. And on the left-hand side, we have the function of a. This expression here, this final expression is what the remainder theorem is all about. The remainder theorem is basically used whenever we are trying to get or find the remainder without actually going through the division process. So in a way, it's a shortcut of finding remainders from a polynomial when it is divided by a certain factor. So in short, how do we summarize this in a statement? Please repeat after me. The remainder theorem states that if a polynomial is divided by x minus a, then the remainder r is equal to p of a. And how do we go about applying this remainder theorem? We will understand that later on in this video once we start doing exercise 5.2. Also, another theorem which is right adjacent or right after the remainder theorem is called the factor theorem. Now, I want you to imagine a situation where when you are dividing a certain number, let's say you are dividing 12 by 3, what happens? We know that 3 times 4 is a 12, and so we see that there's no remainder at the end. So whenever we are dividing, there are certain situations where you have a remainder, but then there are other times when we do not have a remainder. So if, let's say, we have a situation where the remainder is 0, when the remainder is 0, then that means our p of a, which is equal to the remainder in this situation, is 0. So when this happens, we say that when r is equals to 0, that means p of a equals to 0. So when that happens, that means then the divisor x minus a is a factor of the polynomial px. Let's understand that one more time. When we say that in a certain situation there is no remainder, then the divisor here, is said to be the factor of the polynomial or the dividend. Over here also, when we were dividing this expression, when we were dividing the polynomial x squared plus 3x plus 2 by the divisor x plus 1, we saw that the remainder was 0. So when this happens, we can then conclude that x plus 1 is a factor of the polynomial x squared plus 3x plus 2. This here is called the factor theorem, which states that when p of a equals 0, then x minus a is a factor of px. These two theorems are going to be used in the exercises that we are now about to start.